A single slit has a width of 0.13 millimeters, okay? I like to, the data packet says that it has this formula, right, for diffraction. That is that what theta is lambda over b, where b is the size of the opening, and that works. That we can work with that, right? So that's the wavelength, that's the size of the opening, right? The width of the slit. Right. Now, what you got to understand in this diagram, right, is that there's a central pattern here. And look at how these things are evenly spaced. Each one of those little ticks there has a width. That theta is, between here and here, is lambda over b. Okay? And this is also, this is out here, this is lambda over b, lambda over b. All of those things have the same angular width. Okay? So one way to figure out the angle is that it's some number. Okay, I'll say n times lambda over b, right? Where n is how far over we are. So if we're saying the distance from here to here, then it would be 1 lambda over b. If the distance is from here to here, that'd be 2 lambda over b. If it's from here to here, as it is in this question, it's 1.5 lambda over b. Okay, if it's from here to here, it's 3 lambda over b, because it's 1, 2, 3 lambda over b's over. Okay, now that's one way to figure out the angle. And then the other way to figure out the angle is that the angle is just simply the distance on the screen divided by the distance to the screen. This is the basic definition of angle. And of course, this is angle in radians, right? Okay, so let's take a look at this thing here, right? We know that b is equal to 0.130 times 10 to the minus third meters. It's illuminated by light. Oh, we got to figure out the wavelength of it, right? Okay, we know the distance to the screen is 1.51 meters. And we know that this distance right here, from here to here, okay, that distance there is 0.857 centimeters. Okay, so the distance on the screen is 0.857 centimeters. Okay, so one expression of the angle is that angle is 0.857 times 10 to the minus 2. That's centimeters, right? Divided by 1.51. And another expression of the angle is that on the screen it is not just lambda over b, but it's actually from here to here is going to be 1 lambda over b plus a half lambda over b, because we're at the crest of this thing, right? So it's 1 lambda over b plus a half, so 1.5. And then we don't know the lambda, right? But we do know that the b is 0.130 times 10 to the minus third meters, okay? So now I think we can solve lambda, right? We know that the distance, the actual angle is the distance on the screen divided by the distance to the screen. And then we know as far as the wavelength goes, that's 1.5 wavelengths difference, right? And we go that divided by the b. That's what this thing is for, okay? So now we're set. Now we can solve for that lambda. Let's see if we get the right answer. It's going to be 0.857 times 10 to the minus 2 divided by 1.51 divided by 1.5 times 0.13 times 10 to the minus 3. And sure enough, I get the same answer I got before. Hopefully it's right. Okay, I get 4. So lambda is 4.9187 times 10 to the minus 7th meters, which is the same as 492 nanometers. Woohoo!